Pursuit is an extensible direct manipulation interface to a file system that focuses on adding programming capabilities directly in the interface so that novice and non-programming users can automate routine, repetitive tasks. To construct a program in Pursuit, users demonstrate its actions on real pieces of data, and Pursuit creates a more general procedure. During the demonstration, the developing program is represented in an innovative visual programming language, which also serves as a unique form of feedback between Pursuit and the user. Unlike other visual languages, which are often based on the data flow model and which explicitly represent operations with icons, Pursuit's visual language is based on the comic strip metaphor and explicitly represents data, such as files and folders, with familiar icons. Two panels are used to represent an operation. The prologue shows the data before the operation, and the epilogue shows the data after. The changes in the data icons imply the operation. In this way, Pursuit programs reflect the objects and changes seen in the real interface when the operation is executed. We begin by writing a program to back up all the .tex files that were edited on August 19th. When we enter record mode, a special program window appears. After we select all the .tex files that were edited on August 19th and copy them, a representation of the operation appears in the program window. The upper panel is a declaration. It defines the red set of files icon to be the .tex files in the root folder that were last modified on August 19th. The date string is an attribute and represents an inference made by Pursuit. When the copies are moved to the backups folder, a new panel is added. The blue icon for the copies is now in the backups folder. Only one panel is added because Pursuit notices that the epilogue of the copy can also serve as the prologue of the move operation. To change the names of the files so that they don't say copy of, we first change the name of one file. Two new panels are added because the prologue of the rename operation could not be combined with the epilogue of the move, as indicated by this space. When we delete the prefix from a second file, Pursuit notices a repeated operation. It highlights the two iterations and asks if we would like to collapse them into a loop. Pursuit then attempts to identify the set over which the loop will execute. It highlights the set's current members and asks us to verify its guess. The icon used in this dialog box is the same one used for the set in the visual script. A positive reply causes Pursuit to finish executing the loop and update the visual script. The loop is implicitly represented by the rename operation applied to the set of files. The black shadow indicates that instead of adding a new panel, Pursuit altered the epilogue of the move operation in order to save space. Clicking on it reveals the individual operations, and clicking on the black box recombines the panels. After we stop recording, we can edit the script. Attributes can be edited via a property sheet. Currently, the set of properties Pursuit supports include name, location, date, size, owner, and contents, and the strings can be simple arithmetic expressions containing variables, constants, and references to other objects. Attributes can also be edited directly, and the changes are immediately propagated throughout the script. To save a program, we give it a name and select parameters. To specify parameters, we click on any file, folder, or property in the visual script. These parameters can be named, and parameter names are immediately changed in the script. The new program is added to the list of user-defined programs and can now be executed. For example, backups of the paper folder can be made by executing the new program on that folder. The next example creates a program to compress all the .tex files in the folder. The example is complicated because the file inter.tex.z will cause the compress operation to fail when it is executed on the file inter.tex. First, we demonstrate a successful execution of the compress operation. Next, we demonstrate the unsuccessful case. When the compress operation fails, it pops up a dialog box to let us know why. And because we are recording a script, Pursuit pops up this meta-dialog box to ask if we would like to see the first dialog box when the script is executed. The unsuccessful compress operation is added to the script. The predicate after its prologue depicts why the operation failed. This icon represents a dialog box, and clicking on it pops up the Pursuit meta-dialog box just displayed. We continue by demonstrating what the program should do in this case. We delete the problem-causing file and re-execute the compress operation. Once Pursuit has detected the real loop, it asks us to indicate the set to loop over. We select the current set members, and Pursuit infers the set definition. Pursuit then completes the loop and updates the visual script. Here we have an example of an explicit loop containing a conditional. The declaration defines the loop set inferred by Pursuit. The loop operations are contained in the outer loop rectangle. The black square on the prologue of the compress operation indicates that the program branches at this point, and clicking on it reveals the other possible outcomes of the compress operation. These two examples have shown some of the many unique and innovative aspects of Pursuit. By combining the techniques of programming by demonstration with an editable visual language representation, users can create programs containing loops, variables, and conditionals. The types of programs possible in Pursuit cover many of the tasks users often write shell scripts for. Studies are being done to see how easy it is to construct programs using Pursuit.